and best practices. Commands represent a request to change the state of the domain. They can be rejected and are usually phrased as a request. A best practice is to define commands that are intent revealing, and this means that you can see from looking at the command exactly what it was trying to do. We should therefore favor commands that are more specific rather than more general. Which of the following would be a better command to set the table number for an order? Set table number uh, table number for an order. Set table on order. Mm, Set table on order. Assuming we have defined our bounded context to include orders, payments, menu, customers, reservations, which of the following represent commands in the order context? Uh, Order. So add an item to the menu. Hmm. So it's more like a menu instead of order. Add an item to the menu. Open an order. Open order. Add an item to an order. Collect payment for order. Payment. We have payment here. Assign a server to an order. So yes, because there is no server bounded context, this one should bound it to an order. So I'm gonna choose this one too. Events best practices. Events are often the result of a command, where a command requests a change to the state of the domain and event records that change. They often exist in a one-to-one relationship with the command because they record something that happened in the past. They are best written as a past tense. As we um, studied about the three activities, one was command, the next one was event, the other one is query, and then events explains the status that already happened. So add an item to an order means that it's more command. An item was added to an order. Item added to an order. An order was updated. Order updated. An item was added. Item added. None of the above. But here, an order. So, which of the following would be a pre an add an item to an order? Add an item. Item was added to an order. Item added to an order. So assuming we have defined our bounded contexts to include orders, payment, menu, customers, reservations, which of the following represent events in orders context? Price changed on menu item. So it says in the menu, price changed on item. An order was closed. Order closed. The table was assigned to an order. Table assigned to order. Customer address was updated. Customer address updated. Here. An order was placed. Order placed. Assuming we have defined our bounded contexts to include order, payment, menu, customers, reservation, and order closed, price changed on item. Why suddenly item? Uh, the table was assigned to an order. Table assigned to order. Customer address was updated. Uh, uh-huh. Event define a bounded context to include all most events in uh, order context. Oh, order context. Sorry. Price change in the menu is not about the order, but in the menu. And an order was closed. Yes, order is closed. The table was assigned to an order because we don't have a table, so it's possible. Customer address was updated. It's more like a customer thingy. An order was placed. Order placed. So those three. Query best practices. Queries can be done to obtain information about the state of the domain. A query is issued in the form of a request for information, but it never changes the state of the domain. If you perform the same query twice without any other actions, then you should always get the same response. Which of the following does not represent a good query for our orders context? Get or update order by ID. Get closed orders, okay. Get order by table. Get open orders, yes. Hmm. Um, shall we see what are all left in our courses? So domain, still we have a couple of no, like not couple of 1 2 3 4 5 6 and then 7. I guess these are not important. Seven of them are left yet. So in my to-do list, mm, 5, 9, 11, something like this. So which means I have paid um, 20 hours for free code camp, 100 hours, and then 20 hours So uh, mhm. Because I finished something like this. So let's listen to the domain object.
Previously, we outlined the different types of activities that we encounter in our domain. Now, with event-first domain-driven design, when we are defining what those activities are, the reason that we're doing it is in part to help us drive out what our bounded contexts are, but also to help us define what the objects are that we're going to encounter within those bounded contexts.
Event-first domain-driven design.
So let's have a look now at what types of objects we are going to see when we start diving in more deeply into a bounded context. So one of the objects that we're going to encounter is what we call a value object. Now, a value object is defined by its attributes. So we see the example here of an address. In the first two boxes, we have an address which is 1234 Play Street in the city of Loganville, the state of Arkansas, that's not a typo, and the country of Lightbendy.
Arkansas, that's not a typo, and the country of Lightbendia.
Now, if you look at the second box, you'll see that it's identical. It has the same number.
CD that isn't identical. It has the same
street,
number,
city, state, country. Because they are identical, we can say that they are the same address. We know that if we go to either one of those addresses, we will end up at the same building. That's the nature of an address. So that represents a good example of a value object. Because of the nature of a value object, it has to be immutable. The reason it has to be immutable is because if we change any one of those fields, it becomes a different address. So in the last example, we see that we've changed the street from Play Street
change the street
to Reactive Lane.
Play Street to what's changed? So Play Street, Reactive Lane.
And when we do that, it's no longer the same building. It's no longer the same address. We're now going to a different location. Therefore, we can say that the value object has to be immutable because any change to it causes it to become a different object. Now, these are typically state containers. They contain data that is often passed between different components in a reactive system.
They can contain business logic as well.
But they can contain business logic as well. So if you want to have some logic that extracts some information out of the address, that logic can exist inside of the address object. In a reactive system, messages are implemented as value objects. So we talked about the message-driven architecture of a reactive system. Message-driven architecture system. These are the messages. They are implemented as value objects, and then they are passed between different components in your reactive system. Now, to contrast that, we also have something called entities. Now, an entity is defined by a unique identity, like an ID or a key. So if we look at our example here, we have our person, John Smith, in the first box there. Now, John Smith is going to be defined by a single identity, which in this case we've chosen to be name. Now, I realize that name in a real use case is actually a terrible unique identifier, but we're going to use it in this case just so I don't don't have to try to recite a UUID or something like that. So we're going to say that for our domain, for whatever reason, John Smith, or his name, is an appropriate unique identifier. Now, if that's the case, then we can look at John Smith's attributes. We can see that he's 5'11", 185 pounds with brown hair and blue eyes. But if we compare that to the second instance of John Smith, we see that the name is the same, but some of the attributes have changed. So his weight is now 175 pounds, so he's lost some weight. That's good for him. And it looks like his hair color is now red instead of brown, so he bought some hair dye. Okay, no problem. It's still John Smith. The person hasn't changed because, again, he is defined by his unique identifier, which is his name. The attributes have changed, but that's okay. Now, on the flip side, if you compare that to the last box, we see Jane Smith. Now, in this case, our unique identity has changed. We don't have the name John Smith anymore. We now have the name Jane Smith. If you look at the attributes, you'll see that the height, weight, hair color, and eye color are all the same as our last version of John Smith. But we can say that this is not John Smith. This is Jane Smith. This is a different person. So what we're saying here is, with an entity, first off, entities, unlike value objects, can change. They are mutable. So the attributes can change, and it can still maintain its identity. Entities are the single source of truth for a particular ID. So if you want to know anything about John Smith, you can go to the John Smith entity, and he can give you those answers.
You can go to the John Smith entity, and he can give you those answers.
He can tell you his height, his weight, his hair color, his eye color. So it is the single source of truth. Entities are often workhorses for mutable state, but also for business logic. They often contain a lot of business logic that says things like, when I want to change a particular attribute, this is how I do it, and these are the rules associated with that change. In reactive systems, if we're building using akka, actors are an excellent model for entities. They have a unique identity in the form of an address. They are mutable. You can change their state in a safe way. So they make excellent representations of entities. Logum is built on top of akka actors and actually or takes that concept and gives it the exact name out of domain-driven design. It calls them entities. So we talked earlier about how
it calls out entities.
How in reactive systems you'll often see a lot of the domain-driven design terminology.
We talked earlier about how it represents a system. You will often see a lot of domain-driven design terminology in those systems.
In those systems, this is an example of that. There's also a specific type of aggregate, which we call, a specific type of entity, which we call an aggregate. Now, an aggregate is a collection of domain objects bound to a root entity. So here we see a person that consists of a name, an address, and a phone number. That name, address, phone number, and person make up an aggregate. Now, the root entity here, and it is all...
One more time. The root entity here, and it's always an entity, it's called the aggregate root. Aggregate root, this one. The aggregate root in this case.
Always an entity is called the aggregate root. So the aggregate root in this case is the person. Objects in an aggregate can be treated as a single unit. So you can say that a person consists of a name, an address, and a phone number, and those are all part of a single larger whole. Access to objects in the aggregate have to go through the aggregate root. Remember, an entity is the single source of truth for any particular piece of data. Same thing with same thing with an aggregate. It is the single source of truth. So if you want to know the truth about that person, you have to go to that aggregate root of person. You can't, go directly to the database because the database is not the source of truth. The aggregate is the source of truth. And we'll get into this in more detail later in the course.
More in detail
Transactions should not span multiple aggregate roots. So if you find yourself in a situation where you need to do a transaction that actually crosses aggregate roots, then you've either defined your aggregate roots incorrectly, or there's a problem with your transaction and you might have to rethink it a little bit. Aggregates actually make really good candidates for distribution in reactive systems. So when we start looking at other things later on, such as cluster sharding in Akka, for example, that is something, a good place to start looking to distribute with cluster sharding is your aggregates. Logom uses the concept of a persistent entity, which is backed by cluster sharding, and it distributes those entities or those aggregates across a cluster. So that's a good starting place to start distributing. But how do we determine aggregate roots? Aggregate roots are very important in a domain-driven design system. But figuring out what they are is not always straightforward. There's a few problems. One is the aggregate root can be different from one context to the next. So in reservations, we've decided that the aggregate root is going to be reservation. But if we build a loyalty program, well, loyalty has nothing to do with reservations. So the aggregate root there might be something different, like a customer, for example. In addition, you can encounter situations where a context may require multiple aggregate roots. It's not common. It's far more common to see a single aggregate root per bounded context, but it's not always the case. So some questions that you have to consider are, is the entity involved in most of the operations in that bounded context? In the reservations context, I think we can clearly say that almost every operation, probably every operation, is going to involve a reservation in some way. So it probably makes sense that that would be a candidate for our aggregate root. Another question to ask is, if you delete the entity, does it require you to delete other entities? Well, if I delete the reservation, then I don't really need the time for the reservation. That's not really that important. Arguably, I don't really need the customer for the reservation anymore either. Now, you might say, yeah, but if you delete the reservation, doesn't mean the person isn't still a customer. And that's true, but it does mean that if you delete all of the reservations for that customer, they're still a customer, but they're not a customer who has reservations. So from a purely reservation context, we can say that that particular customer doesn't matter anymore because they don't have any reservations. So in fact, deleting the reservation could actually delete the customer. Will a transaction span multiple entities? If the answer to that question is yes, then we can safely say that we have got the wrong aggregate root, because again, a transaction should not span multiple aggregate roots. So those are the types of questions that we can use when trying to determine the aggregate roots. That should help us build kind of a candidate list, and then from there it's going to be a matter of looking at that candidate list and saying, okay, it's that one. And that's a little bit instinctual. There's a bit of an art to that rather than necessarily being something that we can do scientifically in all cases.
Necessarily being something that we can do scientifically in all cases. True/false. A value object is defined by its attributes, and those attributes can be changed. So once the value object is defined, its attributes and those attributes cannot be changed. False. So value object. We see the example here of an address. In the first two boxes, we have an address which it has to be immutable. The value object, it has to be immutable. Correct. Using the above blank check, it's possible to design an object called check identifier. Check identifier combines a routing number, account number, and check number into a compound identifier for checks. These are the only attributes of check identifier. We can diagram it as routing number, account number, check number. Is check identifier a value object? True or false? Given that check identifier has three attributes that make a compound identifier and has no other mutable or immutable attributes. It is a value object. So once again, if I go back to the previous section, it says the I know it is true, but what I'm trying to double check is that if it is um, if the value object doesn't ever in the value object every um, attributes are part of the identifier. So in the value object um, that we are going to encounter it what we call a value object defined by its attributes. We see the example here on the city. That's the nature of an address that represents a good example of a value object because of the nature of the value object. It has to be immutable. The reason it has to be immutable it because it is change if we change any one of those fields it becomes a different address. In the last example we see that we've changed the street from play street to a reactive lane. When we do that it's no longer the same building, it's no longer the same address, we are now going to a different location. Therefore, we can say that the value object has to be immutable because any change to it causes it to become a different object. So we've double checked. So it is value object. Uh, Equivalent value object. True or false? The above two value objects are considered to be equivalent. Equivalent, of course, because um, true. Yeah, because it's equivalent. Nothing is different. Change the check identifier value object. As a value object, we can change the check identifier account number value, maintaining equivalency. No, once we change this one, it's a now a different one for us. Bounded context A, check identifier, bounded context B, value object and messages. True or false? It is possible to pass check identifier as a message between bounded context A and bounded context B. Uh, hmm. In a reactive system, messages are implemented as value objects. We talked about the message-driven architecture of a reactive system, and these are the messages. They are implemented as value objects and then they are passed between different components in your reactive system. So it's true because this object, value object, is a message, one of the messages. True or false? An entity requires a unique identity. An entity, for example, a key or ID. So I need to check the an entity is defined by a unique identity like an ID or key. If we look at our example here, we have our person John Smith in the first box there. John Smith is going to be defined by a single identity, which is the case we've chosen to be name. True. An entity requires a unique identity. Entity is defined by a unique identity. So in here, is it an entity? Is it an entity? Yes. So in here, bank account, this one is a bank account. Sorry, sorry. While the account ID was 123450, the account type is now changed to checking. True or false? The above bank account is an entity. Bank account is an entity. Yes, true. Because we have identification, account ID, and then type can be changed. Yes. Why is above bank account an entity? Why is the above bank account an entity rather than a value object? The above is not an entity because entities cannot have identities. Wrong. Bank accounts attributes are mutable. For example, the account type value is changed. Value object attributes cannot be changed. Entities always have proper names like a bank account. Always have proper names like a bank account. What's that mean? I'm not sure about that. Bank account has an identifier of account ID with a value of 123450. That means we can determine that our bank account 123450 is the same bank account with an account type of savings. After the type changed, we with an account type of checking. The above is not an entity because entity attributes cannot be changed. Bank account is a value object. I think I have some issue with the peanut butter. Not like a severe um, and the allergy reaction, but it seems like it is choking my throat a bit. Um, True or false? The above two bank accounts are the same bank account entity. False, because the ID is different. True or false? The second above three bank accounts are the same bank account entity. So the ID is the same and the value has been changed and the type has been changed. Yes, but it's still the same bank account. Summit. Aggregate root entity. The above is an aggregate. Aggregate is just assembling yeah. 종합한. Okay. It's an aggregate. What is the root entity of this aggregate? The root entity a specific type of entity which we call an aggregate. An aggregate is a collection of domain objects bound to a root entity. Here we see a person that consists of a name, an address, and a phone number. That name, address, and phone number and the person makes up an aggregate, the root entity here, and it is always an entity. Equals the aggregate root. The aggregate root in this case is the person. Objects in an aggregate can be treated as a single unit. You can say that a person consists of a name, an address, and a phone number, and those. So in here, bank account is the aggregate root. So it's a bank account. So those account ID, account type, transaction, are the entities. True false. In the above bank account aggregate, it is permissible to directly change the transactions or account type domain objects directly bypassing the bank account. In the above bank account aggregate, it is a It is a single source of truth. If you want to know the truth about that person, you have to go to the aggregate root of the person. You can't go directly to the database because it's not about the no. Of course, though those information is only just belongs to the bank account itself. So we can, for example, if you're trying to change an account type of this bank account, we need to go through the bank account and change it. No, no. First, root entity name. What is another name for root entity? Aggregate root. The following questions can help you determine an aggregate roots in a bounded context. The following questions can help you determine an aggregate root in a bounded context. Can an entity be broken up into multiple entities? The following questions can help you determine an aggregate root in a bounded context. Can an entity be broken up into multiple entities? I think so. Will a single transaction span uh, span multiple entities? Hmm. Should be. Does the entity have more than 10 attributes? Does the entity, which entity? The following question can help you determine an aggregate root in a bounded context. Does the entity have more than 10 attributes? Entity. If you delete the entity, does it require you to delete other entities? Following questions can help you determine an aggregate root in a bounded context. So what's the question? Make sure you select all of the correct options. They may be more. Is the entity? Oh, the the. Okay. Can an entity be broken up into multiple entities? This one is the aggregation. Can be the determined for the aggregation root. Will a single transaction span multiple entities? It's not a question. Does the entity have more than 10 attributes? No. If you delete the entity, does it require you to delete other entities? Does the entity state change more than 5 times in a single operation? Does the entity more than Is the entity involved in most operations in the bounded context? Hmm, I think that's the only one answer for this question, but let's see. Um, um, hmm, reservation, but if we build a loyalty program while loyalty has nothing to do with the reservation, so aggregation root there might be something different, like a customer, for example. In addition, you can encounter a situation where a context may require multiple aggregate roots. It's not common. It's far more common to see a single attribute root per bounded context, but it's not always the case. So some questions that you have to consider are: is the entity involved in most of the operations in the boundary context? Is the entity is the entity involved in most of the operations in that bounded context? Is the entity involved in most operations in that bounded context? Because let's consider I'm trying to change the translation. Even though I'm trying to change the translation, it should be passed through the bank account, which means because I'm in this domain and then this is the um, aggregate root, so all the entity that I'm trying to approach is a part of the aggregate root, uh, part of the aggregate entity, and then the aggregate root is the in this case bank account. So yeah, is the entity involved in most operations in that bounded context? Okay. In the reservation context, I think we can clearly say that almost every operation, probably every operation, is going to involve a reservation in some way. It probably makes sense that that would be a candidate for our aggregate root. Another question to ask is, if you delete the entity, does it require you to delete other entities? Well, if I delete their reservation, then I don't really need the time for the reservation. That's not really that important. Arguably, I don't really need the customer for the reservation anymore either. You might say, yeah, but if you delete the reservation, doesn't mean the person isn't still a customer. That's true, but it doesn't. It does mean that if you delete all of the reservations for that customer, there's still a customer, but they are not a customer who has reservations. So for a purely reserved reservation context, we can say that the particular customer doesn't matter anymore because they don't have any reservations. In fact, deleting the reservation could actually delete the customer. Will a transaction span multiple entities? Yeah. Does the entity, if you delete the entity, does it require you to delete other entities? That's true, but it does mean that if you delete all the reservations for that customer, there's still a customer, but they are not a customer who has reservations. So for a purely reservation context, we can say that the particular customer doesn't, in fact, if the answer will a transaction span multiple entities? Will 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 a transaction span multiple entities? If the answer to that question is yes, then we can safely say that we have got the wrong aggregation root. Because again, a transaction should not span multiple aggregate root. Transaction. Have we mentioned transaction before? Transactions should not spend multiple aggregate span. Span should not span multiple aggregate roots. If you find yourself in a situation where you need to do a transaction that actually crosses aggregation roots, then you've either defined your aggregation roots incorrectly or there's a problem with your transaction and you might have to rethink it a little bit. Aggregates actually make a really good candidates for distribution in reactive systems. When we start to looking at other things later on, such as a cluster, sharding, sharding in Akka, for example, that is a good place to start looking to distribute with the cluster shading in your aggregates. So if there is a one domain and then we are dealing with one entity, and then if it is one entity, and then if it is an aggregate root, it means that all the entities that we need to act on with something, and then we need to pass through the aggregate root. That's what the aggregate root means. So, for example, if I tried to pass one aggregate root and the other aggregate roots in the transaction, it is not the aggregation root anymore. There might be a chance to have a higher level of idea that can be the candidate of the aggregation root. So, um, can an entity be broken up into multiple entities? So, for example, in this one is a little bit arguable, but even though there is one aggregate root, but if you don't have any entity, then it cannot be broken. But still, that's the attribute aggregate root, so that's not a right question. I yeah, I have rethought it. Will a single transaction span multiple entities? Will a single transaction span multiple entities? So I have a couple more um, steps to finish my um, lecture of domain-driven design, and then I hope that these two, one, two, three, four, five, six, seven, eight. Oh, wait a sec. No. Um, so one, two, three, four, five, six, six of them. So yes, hopefully I will finish this one till this week, until the end of this week. Then I'd like to start the next lesson for the next week. And then because I finished like 3 hours, wait a sec. Oh, it's not easy. I need to finish. I need to finish all of those steps in 5 years, which means I need to finish like a 6 hours process in a day per day. Um, so it was good job for finishing the free code camp uh, uh, in but lesson two. Actually, it was like a 25 hours. So least I finished the first lesson last week, and then we'll do that. We'll finish 1, 2, 3, 4, 5, 6, 7. Exactly. Huh. Lesson 3, 4, 5. No, I cannot. I can't. It's not in an easy task to finish 3 lessons per week. I learned that. Maybe I can. Yeah. In the morning, finish 2 sections, and at night, finish 2, then 4 of them. So 4 or 5. 5 of them. No, I cannot. Um, um May 24, May 31. Hop, hop, hop. June 7. Hey, consider, consider, uh, consider I finished all of those things in that times, and I believe this one worth worthwhile to have 3 hours per day. No, I mean 1 hour for each single lecture. So I think I can consider those one as a 25 hours exercise uh, for the lessons. See, I think it's not bad, but I need to finish that till June is too late. Uh, June is too